Hello all, this video is on developing graphical applications on a DWIN HMI touch display and interfacing with microcontroller like Arduino. In this video we have a 5-inch capacitive touch display. Please note on the resolution, this is 80480 means 800 by 480 resolution, 5-inch, and capacitive, last letter represents capacitive. This 48270 means 480 by 270 resolution, 4.3 inch, and the last letter R stands for resistive touch. And you have to solder these 6 pins to interface with the microcontroller like Arduino. There is also a connector to fix the FFC cable, that is a flat flexible cable, and you have to use the official HDL662 USB to TTL converter. You can also use this USB to TTL converter made on CP2102, which is easily available in the market. In some boards you have to solder these 2 points, that is to enable the TTL output at these pins. In displays like 4.3 inch there is no such solder. Directly at the 6 pin output you can interface with the Arduino. So you have to take note of this. In higher end displays you have to solder that, and you need one SD card. Maximum 16 GB is supported to download the project file. You can also use the USB to TTL to download it. In this video we will be using this CP2102 USB to TTL, and this is optional. HD662 is optional. You can either use this CP2102 or the official one. In this video we will not be using the SD card method. We will show how to download using the USB to TTL itself. One external power supply is required. I am using 5 volt 1 amps power source, and adapter is 9 volt. Before starting you have to keep ready with the background images and icons. I have some collection of images. I have stored in folder 32 the background images. Note on the numbering of the images. It should start from 0, and all images should match the resolution of the display. Mine is 800 by 480, so all the images should match this resolution. And icons I am storing in folder 42 and 44. Icons can be in JPG or PNG format, and naming should start from 0. This resolution is we have made it smaller as it is icon. DGUS software is a software used to develop the application. You can download it from the official website. Open the DGUS software. No installation is required. It is just a folder, unzip it and then open it. First set the resolution. Ours is 800 by 480. Set the resolution and then the path of the project. Next you have to create the compressed file for the images. Go to display and then select DGUS, and you can get the ICL tool. Click on ICL tool and then select the images to compress. First you select the background images which we have stored in folder 32. Select all the images and then click on open. Now click generate ICL. This background images must be stored under the DWIN_set folder of your project, and the naming should be 32.icl. No other naming is allowed. You have to store the background images in the 32.icl, and again you click on pictures and go to the second folder where you have stored the icons. Select the images and then click on generate ICL and store it as 42.icl, and the next icon where there are numbers 0 to 9, select that and generate it, store it as 44.icl. So this compressed image files are stored as .icl files, and all these files are stored under DWIN_set folder of your project. This is very important as you are going to download the DWIN_set folder to the display. Now we have 32.icl, 42.icl and 44.icl. So compression of images is over. Now you have to add these images. Before that you have to generate the Word file. Click on Word Bank creation under the welcome window and set the display size according to your image size of screen, and then click on generate create. It will take some time. So the word bank file will be created as .hzk file, and this will be stored automatically inside the folder where you started the DGUS software. So copy this .hzk file and then store it under the DWIN_set folder of your project, where we have already stored the .icl files. Now go to the touch and display configuration and click on plus symbol to add the images. That is, you have to download the background images to the project. Select the images and then click OK. Now you have got all the images under the application. That is the application window where you are going to develop the screen for DWIN display. We have 6 images, and you can click on save. This is the first image where you have a power button. Now go to the touch control and then select basic touch and then draw a box over this power button, on button. To the right hand side is the properties. You can click on button effect set and you can select the second image. That is the same image, just a click effect. And at the bottom you have page switching. You have to click on set and select the home page. And go to the second image. Here this is only a visible image, and the third image, that is 2.jpg, which is the home page. We have a slider, one airflow icon, and a timing display. You click on basic touch module and draw a box on the first slider, and go to the right hand side settings, select the page switching set and select the 3.jpg. So on touching this slider, it will land on the 3.jpg screen, and go to the next section, that is a right airflow symbol. Draw a touch box on the right hand side. You select the page switching to the 4.jpg, and finally the timing section. Draw a basic touch box and then go to the properties, set the page switching to the 5.jpg, and also we have some home symbol. You select that symbol on each screen and go to the page switching and select the home page, which is 2.jpg in our project. Same way, go to the page 4, that is the 4.jpg, and then the 5.jpg, and the home icon. Click on the basic touch and direct it to the page switching, that is the home page. So this is the initial basic touch setting. Finally click on save, and to preview, go to display and click on the preview button. Preview from first page. A separate preview window will open where you can see the display in action. There is only the page switching settings we have done. So the page switching is working as per our design. Double click at the bottom to quit the preview. Now the actual design, that is a 3.jpg, that is a slider, yellow slider. Over this you have to draw from icon display, select slider display, draw a box over this. To the right hand side is the setting. First setting is the VP address, which is very important. This is a user defined variable address, very important to access data from Arduino. So the total out of 128 KB RAM, VP range is you can use 5000 to FFFF. 120 KB space is for user defined VP address. So initial value and the final value we are using 0 to 255, and then set the icon, select the icon file and select the slider icon, that is the icon to move over the slider, and the display mode is transparent. So this is the first setting, is icon display, slider display, and the second setting over this slider display, you for the touch, go to touch control and then select the drag adjustment. make a box under the empty space on the image. Later we will overlap on the slider. At the right hand side, you enable the data auto uploading. This is very important so that you can access from the Arduino. And the VP address to be same as that of the slider display. We have used VP address 5000, so use the same address. And the data return mode is integer, and the start value is 0, and the terminal value is 255. Now the drag adjustment and overlap it on the slider display. At the bottom there is a box where you have to display the values. For this, you go to the text show and then select the 1, 2, 3 data variable and drag a box, draw a box over this space. To the right hand side, select the VP address. It should be same as that of the slider, which is 5000, and if you want, you can change the color, and then the word bank, which we have created .hzk file, that is 0, and then the font size, that is make it as 50, and the alignment is center, and variable type is integer, and the integer digits total 3, so we have to display 3 digits on over this box, and the initial value is 0. Now click on file and then save. For preview, go to display and click on the preview button. A preview window will open. Go to the slider image and drag the slider. You can see the values changing from 0 to 255 as per our design. As we are going to use the analog write in the Arduino, we set this value from 0 to 255, that is 8-bit. So double click at the bottom to close this preview window. Now the next page design, which is the 4.jpg, where we are going to display the icons as per the up and the down arrow. At the center we have a airflow image. Over this image, click on icon display and then select the variable icon and drag a box over this image. To the right hand side of the setting, most important is the VP address. Set the VP address to 5500 and then select the icon file and minimum 0, and then set the icon ID. A separate window will open. Here we have selected the wrong icon file. Go back to icon file, select the correct icon file 42.icl. Set the icon ID to the first image of the airflow and click on OK. And next is the maximum. Click on maximum, that is 4, as you have got 4 images, and then set the icon ID for this maximum image, that is the final image of the airflow. That is step by step increase, and click on OK. Icon ID maximum, set it to 0, as we have got 4 images, 0 to 3. Now we have to set the increment and decrement for the touch control of up arrow and down arrow. Go to touch control, select the increment adjustment, draw a box over the up green arrow, and to the right enable the data auto uploading so that we can access control from Arduino. And then VP address 5500, which is same as that of for the icon. This is very important, and select the integer as you are going to output integer. And adjustment method, select plus and output limit operation is stop. Adjustment step length is 1, lower limit is 0, and upper limit is 0. Upper limit is 3, as you have got 4 icons, 0 to 3. There is constant setting. Touch effect is constant setting. And same way, go to the left down arrow, draw a box, increment adjustment, and the VP address is same as the previous one, that is a 5500. Enable data uploading, and adjustment method is now minus as we are going to decrement. Step length is 1, lower limit is 0, upper limit is 3, and touch effect is That is you select the disposable setting, the previously also disposable setting, and click on save and go to display preview. Now click on this up arrow button, you can see the icons varying, and click on the down button, the icons are varying in the decreasing mode, up and down. So this is only a icon display. Now for the final image, that is a 5.jpg, which is the timing display. So click on instead of variable icon, we'll be using the artistic variable. Click on artistic variable and drag a box over the center portion. To the right hand side is the VP. Now set the VP as 5800. This is the VP address we'll be accessing from Arduino. And click on icon file. Select the correct icon file where we have stored the 0 to 9. And then select the start icon. Start icon is 0. So we have to only select the start icon. The numbering should be from 0 to starting from 0. This is very important. And the variable type is integer. And alignment is center. And for the plus and minus symbol, we have to do the touch control increment adjustment. Draw a box over the plus symbol. The enable data uploading, VP address is same as that, that is the 5800, same as that of artistic variable. Select integer. Adjustment method is plus, and adjustment step length is 1. Over limit operation is stop. Lower limit is 0, and upper limit is 9. As we have got the 0 to 9, that is the artistic variables, we have got 0 to 9, so we set it as 0 to 9. Same way, the draw a box on the left hand side, there is a minus. Enable auto uploading. Set the VP address as 5800. Set it as integer. Adjustment method is minus. Step length is 1. Over limit is stop, and lower limit 0, upper limit 9. Now click on save and go to the preview window. Select the final image, timing image, and click on plus and minus. You can see the icon, that is artistic variables 0 to 9. Next we'll see how to use the inbuilt debug facility of the software. For this you need this USB to TTL device. Just plug on to the USB port of your PC. No other hardware connection is required. Just plug on. We'll be using only the port allotted to this CP2102 USB to TTL. Now go to the display preview window. Open the preview window. At the right hand side you can see some settings. Click on refresh to select the port of the USB to TTL and select the baud rate. You can select any baud rate, 19200 select. Click on open port. At the bottom you can see a record button. Click on the record button. Separate window will open where you can see the hex datas. Go to the preview window, go to the slider page and drag the slider. You can see some hex data on the read window. So here first is the 5A A5, which is the header, and 06 is the number of bytes following. 83 is the hex code for read, that is we are reading from the VP address. Next to the VP address. VP address of the slider is 5000, that is the VP address shown here. And next is a 01, that is a one word of data. Final 2 bytes of data, that is one word. Here you can see a data of 1C. Let us open the Windows calculator, go to hex, select feed in 1C. So decimal value is 28. So that is how it is displaying. Slider, move the slider. Now the slider value is 1 on 9. You get a hex value of 77. The Windows calculator, go to hex, feed in 77. So it is correct. It is decimal is 119. So move further the slider. The value is 181. We get a final data 0085. 85 is equivalent to decimal 181. So go to the next page, which is the variable icon display. Same way, select the port and then the baud rate, and click on open port and then record. In the record window, we get some hex data. While design in the variable icon, we have set the VP address as 5500 and output as integer. So we get this hex data accordingly. First is the 5A A5, which is the header. 06 is the number of bytes following. 83 is read from the VP address. VP address is 5500 of the icon, and 01 word, and final data is 0001, which is the integer value. So according to the up arrow, notice the last byte of data 0, 1, 2, 3, and accordingly it is changing. Same way, go to the final page and click on the timing plus and minus. So integer data is varying according to the plus and minus. Notice the VP address is 5800 and final data 01, 02, 03, accordingly changing. Now let us see how to download the project onto the DWIN display. For this, we'll be using the USB to TTL device. The SD card method also is possible. For this, you can check our previous videos. So connection is we are going to use RX2 and TX2 of DWIN display. TX2 to RX, RX2 to TX, and ground is common. This is very important, and plug into the USB. Provide the power, DC power to the DWIN display. Now from display, click on you finally save it, and then click on generate. This is very important, so that the configuration file is automatically created. This is the DWIN set folder where all the files are stored. That is the ICL file, configuration file, bin file, everything is stored inside this DWIN_set. Go to DGUS and then click on the T5L download. Here we have already done the ICL tool. Now click on the T5L download. There is also CFG edit. If you want to set the buzzer setting or the display direction, anything, if you change and you create manually, then you have to use the SD card method only. Now for now, click on T5L download and select the DWIN_set folder. Select the folder. All these files will be displayed in the list. And finally select the COM port of the USB to TTL. Select the baud rate as 115200 and click on start downloading. So the files will get downloaded onto the DWIN display. .hzk, that is a word bank file, will take some time. It will take at least 5 minutes, and other files will download faster. Only the word bank file will take some time. You can see all the files are downloaded onto the DWIN display. Now in the display, your graphical interface is seen. Now you can touch on the power button, go to the home page, go to the slider window, slide the slider, the value is changing. Go to the home page, select the second project and the variable icon. According to the up and down, the icons are varying, and the timing according to plus and minus, the display is changing from 0 to 9. So before connecting this DWIN display is the Arduino, let us see the Arduino code. In the code, we use the include software serial.h, as we are going to use the software serial, and we use array of type char of size 9, as there are total 9 bytes of data, and the software serial we start the assigning RX pin as 2 and TX pin as 3, and we define the slider as PWM pin 6, and void setup we start the serial .begin at 115200 and DWIN serial at 115200 baud rate, and pin mode we make the slider pin as output, and initially we make it as low, and under void loop we check for the hex data, that is if the serial data is available. Then we use the for iteration loop, and we iterate from I is equal to 0 to less than equal to 8. That is total 9 bytes of data inside that is the total hex byte, and we assign it to the array buffer. So DWIN serial.read data is assigned to the buffer array. we just got total 9 bytes. This is the 9 bytes of data. 5A, A5 is header, 06 is the total number of bytes following, 83 is read, 5500 is the VP address, 01 is the word, and the final 2 bytes of data. So this hex data is stored in the buffer array, and we check for the buffer 0, that is the index 0. As you know, arrays are 0 indexed. The first one is the index 0. We check for the header, which is 0x5a. If it is correct, if the header is 5a, then we use the switch and case statement. In the switch, we use the variable buffer 4, that is the index 4, which is the starting of the VP address. So we check for the VP address at buffer 4, that is the index 4, and we use the case statement. So if the case, if it is 0x50, as the VP address of slider is 5000, we check for the case 0x50, and if it is 0x50, we use the serial.print. That is, serial.print is used for our own debug. Actual data is used in the DWIN serial. So let us print the analog value, which is buffer 8. Buffer 8 has got the value, that is the index 8 has got the actual byte of data. Now let us copy this code and open the Arduino IDE and then edit inside the Arduino IDE. This delay is also important. And inside the case 0x50, let us use the analog write function. Analog write slider, that is the PWM pin, and the data is buffer 8, that is the index 8. We just got the actual data, and we use the analog write so that the value is from 0 to 255. As it is 8-bit, the value is 0 to 255. Now let us connect the Arduino to DWIN display. Remove the USB to TTL device and connect RX2 to TX of Arduino, which is that is the software serial we are using. So TX is digital pin 4, and the TX2 of DWIN goes to digital pin 3 of Arduino. And most important is common ground of DWIN display and ground of Arduino to be made common. And we use LED, we connect the LED at PWM pin 6, that is the digital pin D6. The short pin of LED goes to ground through a resistor, value 330 to 470 ohms, and D6 is connected to the long pin of the LED. Now select the port of the Arduino and then click upload. Now the code is uploaded, and open the serial monitor, and if you slide the slider on the DWIN display, you can see the analog value printed on the serial monitor, and also you can see the D6 pin, that is the LED is connected at D6. So according to the slider value, the LED is fading away, and analog value is written onto the D6 pin where LED is connected. So slider is working fine. 0 to 255 hex value is sent, and accordingly the LED is fading. For testing the airflow icon page and the timing page, let us define digital pins 8, 9 and 10. These 3 pins for airflow variable icon LED displays, and LED at 12 is for timing page demo. We are just making this code simple. And in the case statement 0x55, which is the VP address for the airflow icons, we check for the buffer 8, which is the data, that is index 8, and if it is according to the data, we make the LEDs on and off. And finally at the case 0x58, this is for the timing display, we assign the index the 8, that is a buffer 8, to timesec integer, and according to that value we blink the number of times the LED connected at 12. This is for timing display. So let us connect the LEDs at digital pins 8, 9, 10 and 12, and let us check the demo. Initially the first page is slider page, So the LED connected as 6 is fading according to the value, and the next page is airflow icon. According to the up and down arrow, the LED is connected, glow and off according to the touch, and finally the timing. If it is set to 1, LED blinks once, 2 it is blinks twice, like that. So all three demos are working perfectly. Thank you for watching.